Mike Tung, founder and CEO at Diffbot. Welcome to the Data Exchange podcast.
Ben Lorica, great to be on your show. It's been a while.
Yeah. All right, so I'm on your website. I'm going to read out some phrases here. Knowledge graph, AI web data extraction and crawling. Access 1 trillion connected facts across the web on demand and integrate them with your application. So let's start off, Mike, for our listeners who are not familiar with knowledge graphs. What is a knowledge graph? And in particular, what is Diffbot's knowledge graph?
Yes, so Diffbot is the world's largest knowledge graph. And what a knowledge graph is, it's basically a database of entities and the relationships between those entities. And entities are people, places, and things. So you and I are two entities. We work for two companies. Those are also entities where I'm at the Diffbot office. You're, I don't know, maybe from your home studio. Those are both entities. We live in different cities. So they're real things in the world, basically, right? Unlike data, which is like a representation, of those things in the world. And the relationships are basically how those entities, how they interact with each other. So me as a person, Mike Tung, works at Diffbot, the organization. That relationship is an employment relationship, right? Also, I'm the founder. Also, I'm the CEO. And so these form a graph, and that's what we call a knowledge graph. And
Mike,
yes.
Just very quickly, so why is a knowledge graph more powerful than storing these things in a relational database?
Well, I wouldn't say more powerful, but just different. It's oriented in a different way of storing information than with tables and relations, right? So obviously, data can be stored in various different ways, but there's pros and cons of storing it in these different ways, depending on there's performance reasons, right? Like if it's stored literally on the disk in a certain way, it's faster to fetch certain things when it's laid out in certain ways, right? So when you have highly interconnected data, such as like a graphical structure, right, where there's all these edges, in a traditional relational database, each relation is in a different table, right? Think about CSV files, right, or Excel files, right? Someone might be familiar with. You might have to join many of these files together in order to assemble the information, right? So if you take look up a company, it might have a relationship to its suppliers and a relationship to its customers, right, and a relationship to its employees. If it's indexed around the actual relations, then you have to join multiple tables to retrieve that query. If it's indexed around the entity itself, which is like what the knowledge graph is all about, then you can pull it together much faster. So it enables certain kinds of querying, and it's also it enables certain effectiveness when you're modeling the data as well, right? So we as human beings, I think, naturally think about entities and attaching properties to it. It's also very flexible too, because you can kind of add properties ad hoc to entities, right? Like there's some new thing that comes out like cryptocurrency, and you have all these like attributes and aspects of crypto coins and stuff. If you just had like one sort of like kind of product table, right, and then you wanted to like introduce these as new kinds of products, you'd have to like basically add new columns to that table, right? So you'd have to like modify the whole table to introduce something, to a relational table. With properties, it's much more flexible. You can sort of just like tag them onto the entity.
So what are some kind of common use cases that where a knowledge graph shines? I imagine search is one. People have said recommendations. So what are some of these use cases where you think it makes sense to start thinking about knowledge graphs?
Yeah, so Google really first popularized that word with the Google Knowledge Graph, which was basically a startup they acquired called MetaWeb. And they had this knowledge graph called Freebase. And then that's what you see when you search for something on Google. On the right-hand side, you see these knowledge panels, right? So that's when people refer to search, they're referring to how showing like this information in a knowledge panel is very useful when doing searches. Another thing people mean is that, most of these major companies now have knowledge graphs. Spotify, Netflix, Uber all have knowledge graph teams. And when they're doing search and recommendations within their apps, like when you open up like the Uber Eats app, for example, it's recommending like dishes and stuff for you, right? It's pulling that from a backend knowledge graph where they have modeled out like all the dishes and all the restaurants and all the locations. And so using that information in when doing ranking is very natural, right? To produce better recommendations and also more explainable recommendations, right? So one great innovation from having the ability to sort in a knowledge graph, like on Netflix, instead of just like giving you like a sorted list of movies to watch, it'll say like, you might like this film because you like films that are action movies, right? Or sci-fi, or that have a strong, heroine, feminine lead in it, or Marvel movies, right? So these are all attributes that are attached to those movies in the knowledge graph. And so they can actually explain the recommendations like using the graph. So that's another benefit, over.
So if
traditional
I'm a data team in a company and I want to start experimenting with knowledge graphs, one, I need tools to build them. I need some engineers to figure out how to stand up a knowledge graph. So one advantage of Diffbot then is I can dip my toes into knowledge graphs without having kind of an infra team, right?
Totally. Well, so you should dive into it, only if you have like a particular problem to solve with it, right? You shouldn't dive into it just because it's a buzzword.
Well, no. I mean, so
but,
let's say I kind of I've been talking to other companies and they're telling me, hey, you should investigate knowledge graphs for recommendation. So as a prototype, maybe I can experiment with knowledge graphs that are available as a service, right?
Yes. Yeah. So let's say you're, Pinterest, for example, right? And you want to use, or some company like that. And let's say you want to experiment with how can knowledge graphs improve the search, right? And you'd like to build a demo or a prototype. So there's various things to consider. One is like, what actual database do you want to store it in? So there's actual graph databases, right? Like Neo4j is an example of that category. There's actually what are called triple stores, right? Like Stardog, things that will store them in triples. And then you can also store knowledge graph in a relational database too, or in a document-oriented database. Like
nowadays, Mike, one of these modern data platforms that separates storage and compute, like cloud data warehouses or lake houses, right? Snowflake.
Correct. Yeah, you can put it into Snowflake. So there's the question of where you want to store your data, and there's various vendors that are like database software, and then there's Diffbot, which is actually a data source, right? So there's not too many companies in our category, which is we are a knowledge graph. And how we can help in standing up a knowledge graph is you could actually import entities from the Diffbot knowledge graph, and you have basically a starting point for your knowledge graph already, right? So if you are, for example,
or Diffbot itself is a knowledge graph which has data, and I can augment my models with Diffbot.
Exactly. Right? So either you could just wholesale populate your knowledge graph with the Diffbot knowledge graph initially. Let's say you're recommending restaurants, right? We have all the restaurants in the Diffbot knowledge graph. So you could pull in all the restaurants in Palo Alto from query ours and just dump them into your database. You have a starting point. Or if you already have a database, you can use it to enrich what you have existing, right? So let's say you have a database of customers in your CRM, right? Or your customer base, but you don't have perhaps a field like the location or the star rating, or you don't have like where their headquarters is or how many employees they have. You can selectively pull and augment your database with our knowledge graph, right? So the benefit of that is like things change in the world with entities, right? Like companies get acquired, things move, and your data quickly gets stale. And it's a common problem in any enterprise, right? But by synchronizing it with the world's largest knowledge graph with Diffbot, your data will always remain current and up to date as the world changes.
So knowledge graphs and graphs in general, when people talk about them, Mike, the people behind them always brag about size, right? So I have this many nodes, I have this many edges, and so on and so forth. So, but in general, if you were to evaluate a knowledge graph yourself, what are some of the key facets and things that you judge a knowledge graph by?
Yes, that's a really interesting observation. I think like the size thing is sort of like a phase, right? So if you remember like when it was like Google versus Bing versus Yahoo, they like compared index sizes, and now they sort of just stopped keeping track, right? Like Google doesn't even show like out of how many results anymore when you search for something, anymore. So at a certain point, it doesn't, maybe at the beginning, it's like, okay, we have a large knowledge graph, but then it's really about the quality of the knowledge graph, right? When you're doing any kind of business application, right? So when customers are typically working with Diffbot, evaluating it during the POC, during the trial, the main metrics they use to evaluate are not like just like absolute size of our knowledge graph, but like what is the realm of like the companies I'm interested in? What percentage of those are in the Diffbot knowledge graph, right? So what's like the coverage rate, and then what's like the precision, the recall of the facts in the knowledge graph, right? Like if we spot check them and we benchmark them against our gold data set that's produced by human beings, like is the AI generated knowledge comparable to like the human curated knowledge that the reps are updating in their database, for example, right? So those metrics, beyond size, accuracy, depth, so how many properties, how deep is the graph, freshness, like is the data updated quickly? Like if something changes in the world, like how quickly is it reflected in the knowledge graph? These are all like actually much more important and nuanced metrics than just like absolute size.
So to the extent you're comfortable, so give us some of the kind of classic case studies and use cases for Diffbot. So in other words, if I put you on the spot and tell you, hey, Mike, I'm giving you a speaking slot, and you have 5 slides to kind of explain how Diffbot is being used, what would be on those 5 slides?
Yeah, well, this is more than a hypothetical, right?
Yeah.
But yeah, so our customers, in terms of that use a Diffbot knowledge graph inside their products, it's quite horizontal, as you can imagine, because we basically offer knowledge as a service, right? It's almost as broad as AWS, which offers compute as a service, right? But there's some general patterns. First of all, there's people that are building consumer applications, and there's people that are building business or enterprise applications. On the consumer side, we have other major search engines that use Diffbot. So like DuckDuckGo is powered by Diffbot, things like Microsoft Bing, things like product search engines like Amazon and Walmart.
So wait, so why don't the search engines build their own?
Well, so in the case of DuckDuckGo, they actually don't crawl the whole web. It's very difficult. They actually blend the Bing crawl and then with the Diffbot crawl of the web. So crawling the web is very difficult. There's very few companies. There's only 3 actually major US entities that do a full web crawl, Google, Bing, and Diffbot. And so that's one reason. We have a copy of the whole internet in our data center in Fremont. Yeah, they use them to power like these knowledge panels inside their products. Consumer search, a lot of mobile apps use Diffbot, so people might not be aware, but Snapchat uses Diffbot. The articles feature, the stories come from articles entities we found in the Diffbot knowledge graph. There's various e-commerce and shopping apps like Zola, which is like a wedding planning app, and then these Honey, like these comparison shopping apps, where these browser extensions where you click them and you can find the cheaper price for a product elsewhere, are powered by Diffbot. On the enterprise side, we have all manner of market intelligence. We have business databases like Crunchbase and CB Insights and PitchBook that are powered by Diffbot, and a lot of financial use cases, hedge funds and quant firms using it as a source of alternative data.
So you talked about people building consumer and enterprise apps.
Yes.
What about the users? Are they mainly targeting programmers, or is there a UI for non-programmers?
Okay, so traditionally, we are just basically, we offer our knowledge as a service, right? So you access it via an API, and so we're the data itself, right? So we have what's called the Diffbot query language, which basically you use to query our knowledge graph, and then we have documentation on how to access it. Now we do have like a UI that you can use to basically explore our knowledge graph, and you can use it to form the queries. So we have like a query builder basically, so you can visualize it, and then but very quickly you want to really like dump the data out into an application, your own application, right? So then there's a button you can click that you can like export it as a JSON or XML, or a CSV file. And then after you form those queries, then basically, your application's calling Diffbot now, and it's like for basically integrated, right, as part of your application. So what our users are generally very technical kind of software developers, right?
Yeah.
But then the PMs on the team will use the interface.
Mike, what about the profile of the application? So there's BI and analytics, there's machine learning and AI, there's information retrieval. So I'm assuming you support all of them.
Yeah, well, or just the data. So if you're like, your team is like, that wants to use the data is like, let's say a machine learning or data science team, right? We have many of those that build their own models on Diffbot, they might be calling Diffbot's API from like a Python notebook, right? Or from like a, an ETL like Spark, or one of these data pipelines. There's various ways you can call Diffbot and integrate it into your pipeline. If you're like a true like business BI user that's using Excel and like Sheets and like Tableau, right? We do have actually pre-made integrations for Excel and Tableau, and as well as Google Sheets, where you can just query the Diffbot knowledge graph from Google Sheets. And then if you have, let's say, a table in Google Sheets of like, let's say companies or products, you can automatically enrich that table in place from the Diffbot knowledge graph in Sheets. And so that requires no programming training, right? Or knowledge of how to call APIs to use it that way.
So what are some kind of common ways people use Diffbot data for ML?
For ML, so we have, so there's quite I wrote a blog post about like research published in the last year that cites Diffbot. There's a lot of, it's quite broad. So we work with quite a few academic groups that use Diffbot data in their studies. So one of them is like the University of Alberta, which recently did like a study of like Canadian cultural heritage. So like they got all these documents from Diffbot by running our NLP on it to analyze like all these documents. There have been other groups that have used it to study. We actually just started a collaboration with the Avast AI research team to study all of the privacy policies on the web. So we're able to tell you like which countries have the most readable privacy policies, which companies have the most problematic privacy stance. So that kind of research. There's also people that basically use the raw text data to train their own language models. So since we have a copy of the web, we have the clean text of it. We have clean product descriptions and things like that. So you can use those to, you can imagine, build your own language model or product classifier, content classifier, and spam detector, and so forth. So we have quite a few folks doing like that sort of stuff too.
So I had you in my old podcast in 2016.
Yes.
And time flies, man.
Yeah.
The O'Reilly Data Show, which I will link to in the episode notes of this episode. So a lot has changed in the world of data and machine learning,
yes,
and NLP. So in particular, NLP, transformers, and large language models. So what has been the impact? So first of all, what are the recent progress in any of these areas that you are now using that you weren't using back then, and what has been the impact of all of these progress? So this, by the way, this also includes whatever innovations and progress we've had in cloud computing and hardware.
Yeah, I was just actually literally looking at that podcast from 2016. That was right when I think we got Series A funding for Diffbot, and so it was basically a concept, and now it's real. We launched the knowledge graph like 2.5 years ago, and that was long.
That was long before transformers, BERT, and all of these things, right?
Yes. Well, I think transformers have been around maybe about two years or so now too.
Yeah, but this was
but yes, it was about the same time. Yes, yeah. And so yeah, a lot has changed. Yeah, in the past, I would say 4 years. We have it up and running now, right? With real people and real businesses depending on it. In terms of what's changed in the ML research, large language models, as you mentioned, is a game changer. We have the ability to like fine tune sort of transformers on our texts, right, on the whole web, and multimodal machine learning, right, is now becoming more mainstream. Where I think we were one of only the few people doing it, where we were taking, when we look at a web page, just the pixels and the text and the images on the page, like all jointly together when we extract information. There's some areas that are still quite nascent. Obviously, knowledge graph itself is now a huge thing. So no one said the word knowledge graph at all, right? When we first launched. Now we're the leader in it, and it's like I think something like 10% of papers at a top NLP conference, EMNLP, now mention knowledge. So it's become one of the very buzzy hot topics in natural language processing, is how do you use knowledge when training language models, right? And knowledge graph embeddings, for example. Or
graphs in general. Like I recently looked at the top ML conferences, and the number of papers that have the phrase graph neural networks has exploded.
Totally, yeah.
What
So-
about so Mike? So you're saying you're since we last talked, now the number of people who build ML systems and infuse it with knowledge has exploded.
Definitely, for sure. You definitely seen the explosion in the research paper side. I don't think anyone's truly figured out the optimal way of producing a knowledge graph embedding yet. That's why it's still like a very active area of research, as we haven't totally settled down on the perfect way. We're also actively, we also have our own in-house methods of doing that as well.
You should open source them, because this field needs open source tools too, right?
Totally, yeah. We open sourced a data set called Knowledge Net that I should mention, right? It's kind of like an image net, but for this area of knowledge graphs, which was sorely lacking. We released that in an NLP paper last year. And there's been some labs that have used that data set to validate and benchmark their own what's called automatic knowledge graph construction techniques from text. So there's also, to the point of your other question, is like, what are the trends in the field? Another trend we're seeing is also the importance of like explainability in AI, and how knowledge graphs can really help in as a kind of a counterpoint to kind of just deep neural network systems that are kind of opaque and not explainable. So,
so elaborate on that.
Well, so you know, I assume most people at this point have heard of neural networks, right? And deep neural networks, they're basically like these large matrices of weights, right? And the input goes in, what comes out is basically just a number. And then all in between are all these layers of weights. And so if you were to ask the system, like, why is this a prediction? There's no way very easily from a neural network to see like why it predicts it. And many people have found examples where like very obvious things are just wrong, right? And there's like, it's just like small perturbations will drastically change like the outcome of the prediction, right? So that's the basic problem with the non-ability of neural networks to explain their predictions, right? With knowledge graphs, since knowledge graphs are structured like how people think of concepts, right? And their relationships, and they have human readable labels, right, on each piece of knowledge, they're very explainable, right? So if you make a prediction, like in the Netflix example, you can say, I like it because this is an action movie or has a strong, female lead. So there's a big trend in trying to combine these two, right? So trying to combine the power of the modeling power of like a neural network with the explainability aspect of having human interpretable labels in a knowledge graph to come up with a hybrid system that has the best of both worlds, like high accuracy, but then it can also say, okay, it's because of this and this pieces of knowledge that it can be explained. And also the benefit of that is the human expert, what's called like the SME, the subject matter expert, can now inject their own knowledge into the system and have that being taken into account, right, in the predictions in a much more flexible way, right, than providing labels only or training data, right? So instead of just show me examples of cats and dogs, like I can encode my knowledge in there. So if it has 4 legs, it's more likely to be like, like a cat and dog versus other kind of animals or something like that, right?
So I think so here's a trend that I think you guys fit in nicely to, and this is one of these things which is amazing for us in industry, but there's now amazing for us in that academics are finally catching up a little bit to what the reality is in industry, and this is this notion of data-centric AI, right? So people in industry have long known that you should spend more time working on data. Yes, rather than tweaking your model. But now it's a big trend in academia as well, and yes. People are really focused on all these techniques and tools that will allow you to focus on data while helping your model. So I believe that actually knowledge graphs would be an important component of this, because they're an external data source. That if you develop confidence and competence in using knowledge graphs, I mean, totally. The payoff should be enormous, right, in your model.
Totally. I mean, this goes back when I was in grad school, actually, right, where I started to think of the idea of Diffbot, right, and kind of spun this out from my research at Stanford. In that era, basically, like you could only get a PhD if you come up with a brand new algorithm, right? But then like these ImageNet guys came along and they had this great groundbreaking paper where they just labeled a data set, right? And they used Amazon Mechanical Turk and Google image search.
Right.
And that was like the game changer that led to like the deep learning revolution, right? In computer vision.
Right.
So I believe there's like 3 core ingredients, right? Of course, there's the algorithms, there's the compute and GPU and hardware advances, and then there's the data, right? And at least when I was doing my PhD, I was really struggling to come up with like a new machine learning algorithm. And then I was inspired by the ImageNet folks doing this with vision. And I was thinking, okay, how would you build an ImageNet, but not for vision, right? But for language and understanding. And I started doing back of the envelope calculations, and I realized you cannot build that sort of thing in the same way. You have to use something that can actually mine the entire web and automate this at large scale to build like the structured knowledge base. So I do believe that there are other multi-billion-dollar companies and institutions that are improving the algorithms, right? And all the academic research you can consider in that group, right? There's big companies improving the hardware, right? Like the GPUs, CPUs, TPUs, right? But there's very few companies that actually you can just import a data set from and have a starting point and augment your data and have more actually. And that's like actually a very key ingredient, right? To achieving high performance.
And it's more than actually knowledge graphs also fit into this other trend that I'm seeing, which is basically systems that blend models in domain knowledge and human knowledge, right? So basically, if you have knowledge, you should use it, right? So
totally, yeah.
In other words, if you know something about the physics of your problem, why should you start from zero and use reinforcement learning and brute force your way through the problem, right? So same thing with knowledge graphs. If knowledge graphs will infuse your system with a lot of information that
if you think about how like human beings learn, right? How babies learn and stuff. Most of what you know in your head is actually stuff that you read about or you were told. It's not actually, most of the stuff in your head is not stuff that you learn through direct observation, right? Through like seeing like the pixels in front of your eyes and feeling it. But that's the way we train deep learning systems, right? And that's why they need an enormous amount of training data, right? But you can learn very quickly by reading books, and that's not something you're getting direct experience from reading the book. It's based on what someone's telling you, and they've distilled it already into a simple statement of facts that's being conveyed, right?
Plus, honestly, in some applications, you may not actually have enough data to label anyway, but you have enough knowledge to get going.
Especially for out of distribution, right? Cases where and black swan events and things like that. There's no data, right, around major pandemics, right? So all the models are just suddenly wrong, right?
So what is the knowledge graph community thinking in terms of this whole notion of responsible AI, which is this umbrella term to collect a set of risks around AI? So this includes things like fairness, transparency, like you said, security and privacy, safety and reliability. So what are knowledge graphs in the age of responsible AI?
Yes. Well, the quote unquote knowledge graph community is kind of a weird community. It's like a community of people that were like the semantic web folks, like, over in Europe, right? Yeah. And then there's like the machine. So those people are kind of like, what's called good old fashioned AI, right? GoFi folks, right? That are about representation and logic kind of folks. And then there's like a mixture of like machine learning folks like us that are trying to say, okay, no, you don't need to explicitly model all that stuff. We're just going to learn it from using machine learning. And then there's like industry folks too, right? So it's like a combination of folks. And in regards to like, okay, how to use responsible use and of course, this has become a very hot topic recently because these systems are now actually out of academia and they're actually being used out there in society, right, in the real world, right? So, and I think many,
also at some level, Mike, you're at the level of data. So, if you're not responsible, then the system suffers as well, right? So
totally, yeah. The system, it doesn't work as well. The system has biases in it, right? The system has all sorts of problems. And so what you're starting to see in many conferences and venues is like, there's actually a specific section in the paper that talks about responsible use, ethical implications, and things like that. So I think the general trend is people are starting to consider it now, even at kind of like the grad student phase, right? Kind of the research phase, which I think is a great trend. And then people are also explicitly studying it because they realize that this is not a good system, right? If it's like very susceptible to these small errors in the data, and it's very biased and makes wrong decisions when the training set is biased. And so we're trying to invent ways to debias the data and correct for that and countermeasures for that, which is a very exciting area of research too.
By the way, speaking of which, one area that I forgot to ask you is language, right? So, because our listeners might interpret everything we're talking about as English only. So, to what extent, for example, is Diffbot well represented in non-English languages?
Yes. So, you're absolutely right. Like a lot of these large language models only produce English, right? Like OpenAI's model, I don't think will produce as well in Chinese and other languages. Because of our problem, which is building a knowledge graph from the entire web, we crawl the whole web, and the only part of the web is in English. We have to handle all of the languages on the web, right? So we use multilingual representations that to build our knowledge graph. And one key difference between us and like Google and Bing is we only have one knowledge graph for the whole world. So when you use like the Google search engine or the Bing search engine, and let's say you're a French speaker, right, or you're a Mongolian speaker, you're only querying the French web when you search on google.fr. You're not actually querying all the world's knowledge. Whereas in the Diffbot knowledge graph, we read all of the world's knowledge and we build a single knowledge graph out of it, which is much harder. If any listeners want to check this out, you can go to diffbot.com and click on natural language. And there's like a live demo there. There's no gated access like OpenAI. You can just type in your text in there, and you can type in your native language in there, and you can see produce a knowledge graph comes back that's not in that language. It's in a language agnostic representation, and you'll have the images of the entities and the connections and the relations visualized in the graph for you. There's some pre-filled out Chinese examples or Arabic examples you can try. So that's
of course, you guys don't penetrate the Great Firewall, right?
We're limited to like the public web, but we're quite effective at crawling the public web. So even like really weird areas of the North Korean web, and stuff we can, and where the whole web is like represented in like a network of corrupt PDF files, we can penetrate through and parse, and all the dates are by the year of the founder of North Korea or something, the weird calendaring system.
So what are some industry trends today that you think in a year or two will impact what you're doing at Diffbot?
Great question. There's certain things that are going on in industry research that we're really tracking to the maturity of. One is question answering systems, right? So we're getting closer and closer in the industry writ large to getting really good understanding of question answering.
Are those heavily correlated with progress in large language models?
They definitely help, but there's many different technologies that are used in natural language in question answering besides just large language models as well. And it's also an interesting interplay too between ways of querying knowledge graphs and querying text corpuses, right? And there's also what's called natural language generation too, right? So how do you synthesize it too and generate a natural response back, right? So it's an interesting sort of systems level research area. One area that starting to get a little bit more, we wish there would be more research in this area, is like the area of knowledge fusion. How do you combine knowledge from various sources to estimate the probability it's true when there's different levels of quality of the raw data, right? When you have the different sites out there that are more trustworthy than other sites.
So this is like more accurate. This is like fact checking, sort of.
Yes, that falls into this scoring. And how do you combine different kinds of heterogeneous data? Some might be numerical, quantitative, like is this product, actually 6 feet or 5 feet? There's metric conversions involved in that. Some of them might be combining data that's on the categorical, right? Is this like white or blue? Is this what's the date of this thing? There's not actually, it's very niche. There's not a lot of people, but it's growing. We wish people would do more in knowledge fusion. So that's one thing we're tracking. Multimodal especially as well, is kind of a growing trend. We've seen more and more papers on that, and
So Mike,
we take advantage.
multimodal, I'm super interested in, but one thing I still notice is that when people talk about models, they think about unimodal models, right? So here's my computer vision model. Here's my embedding for natural language. There's no ResNet for multimodal, right? So there's no reference model where people say, oh yeah, this is my multimodal model, right?
Yeah. Well, the question is like which modes, right? So there's like there's image plus text, but there's other modes too, like audio. There's also
but there are there like
also,
breakthrough models that people cite all over the place? No.
There's kind of like some classic ways of like, you know, combining vectors and stuff from different modes, but I don't think anyone's really found it's similar to knowledge graph embeddings, like the perfect way of generating multimodal embeddings yet.
Because short of that, then it becomes kind of still the province of experts and not developers and machine learning engineers, right? So it still needs some level of accessibility, right?
Yeah. I think one reason why it is a hot area of research is that people are still searching for the right answer to the problem, right? It's not solved yet. And so people are trying. Like,
so what's what in your mind? What's what if you were to predict? What's the timeline when we start seeing more common, usable, accessible multimodal models?
Well, I think what's really going to, I guess, increase the quality of that research to get to a kind of a final kind of accepted solution is like the availability of data sets, right? Similar to ImageNet, right? Where we kind of stabilized, right, on these kind of convolutional type networks once that was available. That's one of the problems we hope to solve by collaborating with, what's the reason we collaborate with academia, because we have a unique data set, right, of the entire web and all the different modes that are captured in the various media on the pages. And so by releasing that or allowing academics to evaluate on our data set, we hope, you know, that can lead to like the final right solution for multimodal.
So here's a trend that I've noticed the last few years, which is basically, in reality, we have a lot of models, right? So if you go to certain areas like NLP, you've got model hubs. Computer vision, you have a model hub. So when we do surveys, people say, actually, my problem is not lack of models. My problem is tuning and customizing a model. So I have an NLP model for named entity recognition that works for Wikipedia, but it doesn't work for my very specific application in cancer research, right? So here's where I think if someone could build a tool that combines a knowledge graph and then an off-the-shelf model, use the knowledge graph somehow to tune.
I see. So you're saying
off-the-shelf model.
Perhaps it could take like something from one of these model hubs and then combine that with data from Diffbot in that area.
Yeah, starter model is from a model hub. And then maybe I label a few examples, or maybe I go to a domain-specific knowledge graph, right?
That could be a good business model for us. Yeah, basically take a model from one of these hubs, combine it with taking data from Diffbot in a certain niche that you query, and then
I mean, I think actually
to that niche.
If you look at I think Hugging Face is building a tool like this that makes it easy for people to do transfer learning, because you know they know that there's thousands of models already for people to choose from off the shelf. They work well, but maybe not well enough for you to deploy if you're, because the level of accuracy is not quite there, right? So
I think you always need to tune it to like your own private corpus, right?
Yeah.
I think that's always the case in successful integrations we've seen, where you just have private data, right, that you need to tune it for. But there is like potentially like a level of fine tuning or pre-training so that the model is at least for your industry, right, or in your domain area.
Right.
And then of course you probably do want labels, right?
I mean, I think there's broad areas that even the off-the-shelf model still won't work in, but you might have the data to make it work, right?
For sure, yeah.
And so what's next for Diffbot? I'm sure you're hiring. What are you hiring for, and what are the plans for the company in the next year?
So we're always hiring for people that are world experts in various areas of information extraction, and people that are really great at writing fast, low-level code, right, and C++ and Java, and that can scale some of these research papers right into like one of the largest inference systems, right, that run across the web. But we're also hiring, people that are great at front end and design and stuff as well. In terms of what we're working on today, we're continuing to grow the size of our knowledge graph, the types of entities involved. We're adding new types, like we recently added events and job postings as entities. Our eventual goal is that in a couple of years from now, any piece of public fact or knowledge that you can think of in your brain is in the Diffbot knowledge graph. And so it's really, we've achieved some semblance of comprehensiveness of knowledge, the basic knowledge that we all agree to as a society is in there. That's public knowledge. So that's kind of our goal on the platform side. On the application side, we're continuing to develop business applications. So we're working on a business application that lets you find the relationships between businesses which are similar to each other, and match businesses that we're basically building like a supplier graph and a customer relationship graph. And so we're able to, let's say, take an individual customer and from their list of current customers, calculate the entire TAM of the market. So we're able to see where all the companies globally that look like your customer base, which ones should you be talking to buy your product. And a lot of like sales teams, for example, could benefit a lot from that sort of information, and business development teams.
By the way, so for some reason in my mind, so this is my closing comment and question to you. In my mind, I always associate knowledge graphs with NLP for some reason.
Oh.
It seems like there's two types of graphs, right? Or many types of graphs, but in tech and in industry, you've got the social network kind of graph, and then the knowledge graph. And the knowledge graph, in my mind, I associate with NLP. But you're saying actually it's more than text. It includes images, potentially other forms of media.
Yeah.
But am I wrong to say that most knowledge graphs are text?
I think they're closely associated text because they're basically two ways of encoding facts, right, and statements. And text is just kind of like a serialization of facts, but is one way to communicate between the two. The other is like basically triples, which is basically knowledge graph is basically just a collection of the edges and nodes, which is what triples are. I don't think. Most things that are in a knowledge graph as a triple can be stated as text. So I think that's why you see like that close relationship between the two. And knowledge graph is just a very explicit way of representing knowledge, and text is just another way of representing knowledge, right? That's in a serialized form.
You've alluded to images, but obviously two large sources of data these days are video and audio. Podcasts are exploding, for example, right? So,
but you're right that usually you're trying to extract certain facts from the image and the video, right? Like, is the guy wearing a blue shirt, right? Is this brand in there? So those could also be represented as text as well.
But is this something that you folks are trying to absorb, this multimedia world?
Yeah, we definitely are. The way we use some of those is usually like in our embeddings, right? So we have the Diffbot knowledge graph, which is like the edges and the nodes, but then actually for every node, there's also like an embedding for that node in our knowledge graph, which is a continuous value as well. So we don't expose that in the API by default, but actually some of the research customers, they can actually get the embedding we have for every thing.
So like, for example, Mike, this podcast will be an MP3 file, could be 30, 40 minutes. So, So what do you do with that file? Do you transcribe it or?
Yeah, so when our crawler encounters the page, right, that's hosting the podcast, right, there might be like an image there, right, like maybe like a thumbnail preview. There might be some textual description about that. There might be the audio file, for it.
Right.
Right. So that's like 3 modes already. Right. And from that, we need to come up with like an entity, which is like this podcast. Right. And
Right.
what is it about? Who was in the podcast? Like what color glasses Ben was wearing? Like these are all the things
unless,
that might be.
unless you transcribe it,
Mhm.
if you rely just on my description of it, you won't capture the entire.
Yeah, that's why you need you analyze all modes, right?
Right.
So that's why we do need to transcribe the audio. We need to analyze it in various ways, right?
Yeah.
As well as the video.
Yeah.
Mhm.
All right. And with that, thank you, Mike.
Thank you. Yeah, this has been a great conversation. It was great to catch up.